All right, let's take some time to talk about these things that we know are called parabolas. We've looked at them in previous lessons. They're quadratic equations, they're curves when we graph them, but there's some things that we want to identify about them on a graph that you might be asked to comment on. This parabola has an equation. In this case, it's y equals x squared minus 6x plus 5. And if you were to graph that in a graphing calculator, this is what it would look like. What are the following things? I'm going to get you to try and find for me off here the y-intercept, the x-intercept or intercepts, if there's more than one, we'll look at that in a minute, the vertex, whatever the heck that is, and the axis of symmetry. So let's go through a couple of examples and see if we can identify these things off our parabolas. First of all, the y-intercept, just like in a linear equation, that's just where does the curve cut through the y-axis. This is our vertical y-axis here, and I can see it cuts through right here. This is where my parabola cuts through or intercepts the y-axis, and that is at a value of positive 5. So the y-intercept in this case is positive 5. The x-intercepts, well, if y-intercept is where it cuts the y-axis, the x-intercepts are where does it cut through here, the x-axis. And I can see it cuts through at this point, which is 1. Right, so it's got an x-intercept of positive 1, but unlike the y-intercept, there's actually another one, this point here, right, at x equals positive 5. So my x-intercepts are positive 1 and positive 5. There's two places where it cuts through that x-axis. The vertex is just the tip, right, of our parabola, the point where I guess it changes direction and starts heading back in the other direction. And we're asked to find the coordinate where that is. Well, remember with coordinates, we always go across the x-axis first and then up or down. So I like to think across the hall, then up or down the stairs. So we're going to go across 1, 2, 3 places, and then down 1, 2, 3, 4 places. So our vertex is at the coordinate 3, -4. One last thing to find, and that's our axis of symmetry. Now, symmetry just means when you let's say a mirror reflection of something, so it's symmetrical on both sides. And a parabola is symmetrical, and it has a line that runs up the middle that I guess if you were to reverse or reflect each side of the parabola, they'd be exactly the same. That axis of symmetry always runs through the vertex, and it represents a line. Now, this is a vertical line. So hopefully you can remember from previous lessons, the equation of a vertical line will always start with x equals, in this case, this axis of symmetry, every x value along this line is at 3, okay, because it goes through the point 3, and even up here, the x value is 3, the x value is 3 here. If I go down here, the x value is still 3. All along that line, the x value is always 3, so we say the axis of symmetry is x equals 3. In this case, x equals a positive 3. All right, we found those things. Let's go and have a look at another example, and we'll go through a little bit quicker and see if we can find them. The y-intercept, where does it cut through the y-axis? Right here, at the point at the y value of -3. So I'd say the y-intercept is -3. I can see the x-intercepts are here and here. I've got two of them, right, at -3 and +1. So once again, there are two intercepts, two places where this parabola, bang, cuts through, and then bang, cuts through to get there, cuts through the x-axis. The vertex is the coordinate where the curve changes direction, or the tip of it, and I can see that that is at the coordinate -1, -4. So it has a vertex, oops, my typo there, that should say -1, -4. And the axis of symmetry is, once again, it's a line, a vertical line that runs through that. It's at the x value of -1 is where it cuts through the x-axis. So it'd say the axis of symmetry is x equals -1. All right, what about this one though? Something a little bit different here. This equation, here's the equation for this particular parabola, but you'll notice differently about this one is that it doesn't actually cut through the x-axis. So let's have a look. First of all, the y-intercept, well, that's straightforward. Once again, it cuts it at one place at the value of +1. The x-intercepts though, are there any x-intercepts? Well, it just nicks, it just touches the x-axis, but only in this place here, this one point, okay? It just comes down, just kisses the x-axis, and then it heads back. So we would say it's got an x-intercept at -1, and does it have another one? No, it doesn't. Okay, so it has an x-intercept of -1. That's the only one. It only has one x-intercept. The vertex is at that same point. Okay, so I go across to -1. -1, 0 is that coordinate for the vertex. And the axis of symmetry cuts through -1 for my x value. So it has an axis of symmetry, x equals -1. So unlike the first two examples, this one only has the one x-intercept. Last one, and once again, something different. Let's go through. Y-intercept, yeah, straightforward, no worries. It cuts through the y-axis at a +3. The x-intercept, though, it doesn't. Like, it just doesn't cut through the x-axis at all. It doesn't touch it, doesn't cut through it, it's nowhere near it. So we say there are no intercepts. There are no x-intercepts. It doesn't cut through. The vertex, well, it's got a vertex. It's got a point here where it turns around, changes direction at the coordinate 0, 3. And the axis of symmetry in this case actually sits right on that y-axis. Everywhere along that line, the x value is 0, isn't it? Like if I was to go to that point, it's got an x value of 0. That point has an x value of 0. That point. So we'd say our axis of symmetry was x equals 0. All right, not too tricky. Hope you followed all of that. Feel free to pause and rewind. But just be aware, for the x-intercepts, there might be 2 of them. There might be 1, or in the case that we just looked at, there are none. Well done.